Problem 1. In a class of 30 students, there are 19 who play tennis and 16 who play football. All the students play one of these games. This statement means that in the class there isn't any student who doesn't play a game. Draw a Venn diagram and mark on it the number of students in each region. I'm now going to explain the solution to problem 1. Let T be the set of students who play tennis, and let F be the set of students who play football. On the Venn diagram, the number of students who play only tennis will be written in this region. The number of those who play only tennis is arrived at by subtracting the number of students who play both tennis and football from those who play tennis. That is the total number of students who play tennis. In this region where the rings cross will be the number of students who play both tennis and football. This number is not given in the problem. In this region will be the number of students who play only football. The number of those who play only football is arrived at by subtracting those who play both tennis and football from the total number of students who play football. In the next part, I'll explain how to determine the number of students who play both tennis and football. To determine the number of those who play both tennis and football, I'll form an equation in which the number of those who play tennis and football is the unknown. This equation is formed by adding the students who play only tennis to those who play both tennis and football, and finally you add on those who play only football. The whole of this will equal to the number of students in the class, that is the number of students in T union F. Remember that the number of students who play only tennis is arrived at by subtracting those who play both tennis and football from all those who play tennis. And the number of those who play only football is arrived at by subtracting those who play both tennis and football from the total number of students who play football. Next, I substitute in the values that are given in the problem. The number of those who play tennis is 19. Those who play both tennis and football is unknown, so I'll leave it as it is. The number of those who play football is 16. And the number of members in T union F, or all the students in the class, is 30. This term and this term cancel out, leaving 19 plus 16 minus the number of students in T intersection F on the left hand side of the equation, and 30 on the right hand side of the equation. 19 plus 16 is 35. This stays as it is. This is the number of students who play both tennis and football. The whole of this will equal to 30. In the next step, I subtract 35 on both sides of the equation. This leaves the negative number of those who play both tennis and football on the left hand side, and negative 5 on the right hand side. In the next step, I divide negative 1 on both sides of the equation. This leaves the number of students in T intersection F, or the number of students who play both tennis and football on the left hand side, and 5 on the right hand side. 5 is arrived at by dividing negative 5 by negative 1, which gives 5. Finally, I fill in the numbers in the regions of the Venn diagram. The number of those who play both tennis and football is written here in this region where the rings cross. So the 5 that I got from this calculation is written here. The number of those who play only tennis was arrived at by subtracting the number of those who play both tennis and football, which is 5, from the total number of students who play tennis, which is 19. 19 minus 5 is 14. So write 14 in this region, and following the same procedure for determining the number of those who play only tennis, I get 11 as the number of students who play only football, and the number 11 is written in this region.